In this video, I would like to go over the concept of limiting reactants, sometimes called limiting reagents. And basically, this is the idea that we may not always have as much of both reactants as we need. And so that may limit then the amount of product that we can come up with. You know, for instance, as we've done stoichiometry already in previous videos, you just always assumed you had plenty of hydrogen, plenty of oxygen, and then whatever amount of product you would get from those was just the answer. The problem is, what if we ended up running out of one or the other? You know, let's say I'm making some sort of a recipe, which is the common analogy people use with this concept, and I have an unlimited amount of flour, but I only have a dozen eggs, and I said to you, how many cakes or brownies or cookies can I make? Well, I have truckfuls of flour, so I'm never going to run out of that. It's the eggs that would limit how many cookies or cakes or what have you I can make. So it's the same idea here. If I run out of one, the reaction is going to stop. Now, in the ideal world, we assume I have all of everything that I need, but let's say, and let me show you how this might work. Let's say I told you in a problem you have 8 grams of hydrogen and you have 8 grams of oxygen. Which is my limiting reactant? Which one will I run out of first? There are two main ways to do this. One is to take the one reactant and solve for the amount of the other reactant and see if you have sufficient amounts. The other is to do the plain old stoichiometry problems all the way to the amount of water and seeing which one would give you the least amount of water. And I would basically start with both. So let's just start with that one because we've done stoichiometry already. So let me do this. Let me start with 8 grams of H2, and what I'm going to do is just plain stoichiometry. I'm going to go from grams of H2 to moles of, H2, let me get rid of that, moles of H2, and 1 mole of H2 is going to be 2.0 grams. Then I'm going to go from moles of H2 to moles of the other thing in the equation I'm solving for, which in this case is water, so this will be moles of H2O, Put moles, and when I'm relating moles of one thing to moles of another in the equation, I use the coefficients. In this case, that would be 2 to 2. And then I can go from moles of H2O to grams of H2O. You could actually stop here and go with moles too. You don't have to go all the way to grams, but I'm just trying to illustrate the point, so I'm going to take it all the way. And again, 1 mole of water is 18.0 grams. That is the molar mass that I get by adding everything up here. So if I do all this, I've got 8 over 2 is 4, basically times 1 is 4 still, times 18 would be 72, I believe, if I'm doing my mathematics correct here. So I'd have 72 grams of water if I reacted all of the hydrogen. So that's assuming it all reacted. I had plenty of oxygen, I had unlimited oxygen. I could produce 72 grams of water. Well, let's start with the oxygen this time. And again, as far as significant digits, really I went crazy. To make this work here, I'd have to do 8.00. And again, let me just do that to give us some significant digits to work with here. So let's say this is 8.00 grams of O2. So this is my other reactant. So now I'm going to go from grams of O2 to moles of O2. And again, that would be 32.0. Then I'm going to go from moles of O2 to moles of water. Notice in both cases, the first one I went from hydrogen to water, now I'm using all the oxygen going to water. My coefficient here for the water is 2, for the oxygen it is 1, and again I'm going to go from moles of H2O to grams of H2O. And again, that's just like before, it's going to be 18.0 over 1. Now again, please recognize, you know, a couple of things here. This whole concept, I am taking this all the way out to grams. You do not need to take this all the way to grams as I have done. You could stop at mole and be fine, and you would just go with a smaller number of moles. And some people prefer to do that. Like I said, I am just taking it all the way, just, again, a little further illustration of how you would do these things, but I just want you to recognize that. Now, in solving this particular problem, 8 would be, let's see, 2, this would be 1/4 times 2 would be 1/2 times 18 should be, I believe, again, if I'm doing my math right here, 9.00 grams of water. So if I reacted all of the oxygen, notice that I'm only getting 9 grams of water. So what that means is if I react all of this, I'm going to get a lot more water. If I react all this, I'm going to get a lot less. That means this is my limiter. The oxygen then, in this case, is the one I'm going to run out of first, because it will not, it's just going to produce, this is going to cap how much water I can make. I'm going to run out of that before I run out of hydrogen. Another way to look at that is to literally compare the two to one another. And perhaps that may be more illustrative, I don't know. Let me do that in blue, but let me show you those calculations. If I were to go to, and basically do the same thing, but instead of going from H to H2O and O2 to H2O, let me go from H2 to O2 and just compare the numbers. So, and I'll do this up here, and I'm going to do this in blue, so it's a little bit different. But let's say I do 8.00 grams of H2, and I go from grams of H2 to moles of H2, and again that's 2.0, and then I'm going to go from moles of H2 to moles of O2, the other reactant, and for this I use the coefficients from the balanced equation, and then I go from moles of O2 to grams of O2, and again that's going to be 32 over 1. So again, if you look at what I have here, I have 8 divided by 2 is 4, divided by 2 again is going to be 2, times this would be 64. Make sure I did that right. 32, 8, yes, I believe I did that correctly. So that would be 64 grams of O2. So what this means is that if I reacted all 8 grams of hydrogen, if I reacted all this based on the quantities and the mass in a mole and everything, I would need 64 grams of oxygen. You can see here I'm not even close. I do not have 64 grams of oxygen. So again, we would say that's my limiter. If I go from here to here and react all of this, I need 64 grams. Well, I'm going to run out long before I get there. And so oxygen again is your limiter. Now you could do this backwards and you get kind of the opposite result. So let me start with the 8 grams of oxygen. So if I start with and I'll do this down here, 8.00 grams of oxygen, and I go from grams of oxygen, moles of oxygen, that's 1 over 32, times, and again, moles of O2 to moles of H2. So now I'm going, last time I went from H2 to O2, and I'm going from O2 back to H2. And again, I still use these coefficients from the equation, so this is going to be 2 over 1. And then I go from moles of H2 to grams of H2, and that's 2.0 over 1. Now, if I do my math here, 8 times 2 is 16, times 2 is 32, over 32, I'm going to get 1.0 grams. And again, I'm hoping I'm doing all my math right. I'm just kind of doing this off the top of my head. But notice what's happening here. If I react all 8 grams of the oxygen, I only need 1 gram of the hydrogen, and therefore I'll have 7 grams left. And sometimes you'll get that sort of a question. Somebody will say to you, what's the limiting reactant, and then how much of the other reactant will you have left over? Well, in this case, again, you'll see that I can react all the oxygen, I will use it all up, and I'll use only 1 gram of my hydrogen. So then what you would say is the oxygen, again, is your limiting reactant, because you can react all of it, and you'd say the hydrogen you have in excess, how much will you have left over? The answer to that question would be that you'd have 7 grams of H2 left over. And that would be just kind of excess material that would actually not react in this particular case. So that's the idea of limiting reactants. And again, there are 2 ways to do it. One is to start with each reactant and solve all the way to a product. And if there's multiple products, pick one, it doesn't matter. And then the one that will produce the least amount of product would be your limiter. The other way is to take the one reactant, solve for the amount of other reactant that would be required, and then just simply say, do I have that amount? And then compare it that way. And again, please also recognize that I don't have to go all the way to grams. I could do these equations just to the moles, and of course the moles of water will still be lower here than here. All right, I hope this helps. Thank you very much.